Hi, everybody. Good afternoon to all the people that is connected and the people in the hall. We hope to start on a 3 p.m. time here in Tenerife, just 9 minutes from now. Thank you for waiting. The connection are going well, and the speaker is already connected, and the presentation is visible at this time. So thank you for waiting.
Okay, they are participants of our conference. Then it's time to begin our afternoon session. The speakers are Lohai and Hajiri from University of Pristina, Kosovo. They will speak about application of matrices in real life. Please.
Good afternoon for all of you. We are here and we have recorded the presentation before, and now I will share with you. It is everything okay? You can see my presentation?
Screen. Yes, it's okay.
It's okay?
Yes.
Good afternoon for all of you there and for all colleagues who are attending online this session. I am Stipe Lohai, and with me is my colleague Blerta Selimay. Hi everyone. We are from the Faculty of Electrical and Computer Engineering from University of Pristina from Kosovo. First, I would like to congratulate and thanks all the organizers of this symposium, Professor Rodrigo, Professor Israel, Professor Kostas, and others for this very good organization, in which throughout the week we have seen very important work and experiences in the topics that have been presented. The ITM project has been a very good experience for us as math teachers. We had the chance to use new technologies in teaching so that teaching mathematics is as easy and attractive as possible for the students. Me and Blerta are going to present about the application of matrices in real life. Matrices is a topic, matrices is a topic that we explain with students in first year, in first semester in linear algebra course. Since we work hard to inspire our students to learn, but also love and enjoy math, we have done our best to bring in attention the application of matrices in daily life. We aim for our students to not just understand the theoretical concept, but also know their application and impact in different fields. For this reason, we decided that the topic of this presentation is application of matrices in real life areas, specifically in cryptography and 3D graphic designs. Cryptography and graphic designs in nowadays cannot be imagined without matrices. And to show this, we elaborated two specific examples of their application. And for this, presentation is separated in two parts. In encoding, first is encoding and decoding using matrices, and second is application of matrices in computer design. In the beginning, we are giving the basic concepts of a matrix, such as the definition of the matrix, operation with matrices, and the definition of the inverse matrix. And by the definition, a matrix is a rentabular array or table of real or complex numbers, symbols, or expressions arranged in a row or columns. Symbolically, we write in this form when n is number of rows and n is number of columns. For example, matrix A is a matrix with 2 rows and 3 columns. And as we know, in the set of matrices are defined operations as addition of 2 matrices, multiplication of the matrix by scalar, and multiplication of 2 matrices. And we have several types of matrices, as square, diagonal, scalar, zero, unit, etc. By the definition, the matrix B, the square matrix B of order n, it is the inverse of the matrix A if this equation are completed. If there exists the inverse matrix B of the matrix A, then calculate with this formula. And we start with the first part, encoding and decoding using matrices. One of the most important applications of the matrix of the inverse matrix is in the field of cryptography. Cryptography is the art of communication between 2 people while keeping information secret from others. It is based on 2 factors, namely encryption and decryption, or encoding and decoding. Encryption means the process of transforming information, simple form, into an unreadable form. Decryption, on the other hand, means transforming the encrypted message back into its original form. Encryption and decryption require a secret technique which is known only to the sender and the receiver. The secret is called the key. The receiver decodes the message to receive the original message using the inverse of the matrix. The matrix used for the encryption is called the encryption matrix or encoding matrix. And the one used for decoding is called the decryption matrix or decoding matrix. To use our procedure is as follows. First, we convert the secret message into a string of numbers by arbitrarily assigning a number to each letter of the message. To encode the message, we take a row of encoded numbers and multiply it by any matrix whose matrix has its inverse. Such a matrix is called a key matrix. This new set of numbers represent the encoded as a string of numbers. To decoding the message, we take the row of coded numbers and multiply it by the inverse of the key matrix to get the original row of numbers. Finally, by associating the numbers with their respective letters, we get the original message. In the following, we explain encoded and decoding with an example. Let be the secret message that will send by the sender. I hope ITM continues. And I want to send this message to the ITM project leaders, and I really hope you get my message and the ITM continues or similar project will start. For this process, we will be looking at three matrices, and they are a message matrix, M, an encoding matrix X, this matrix called a key matrix, and must be a square matrix which has inverse, and the encoded matrix E. First, assign your key. We will start simple. In this case, we will take a bijective function between the set of letters and a set of numbers, such as, for example, the letter A is associated with 1, B with 2, C with 3, and so on, the letter Z with 26. The space with 0 and the point with 27. This is called a character key, and in this case it looks like this form. And in this way we turn the sentence into a string of numbers, substituting the letter E with the number 9. After that we have space with 0, age with 8, O with 15, and so on. We get the string of number 2. Then we write this string of number 2 in the form of a matrix, which is called the message matrix. To create a message matrix, we want to use a matrix with 2, 3, or 4 columns. In this sequence, in sequence 2, we have 21 numbers, and divide this by 2, 3, and 4, and see which case is more appropriate. All this if we have not previously given the key matrix. If this is given, we will take columns as the order of the key matrix. You are taking the case when this matrix is not given. Since 21 is divisible by 3, we create message.
Excuse me, Loha. Can I ask?
Yes, please. Yes.
Yeah. Okay. Why the 21 numbers? I am seeing there 18 words. 18 words. I hope item continues, right? This is the coding of this sentence, or
I hope ITM continues.
This is
Maybe 18 letters.
Yeah.
But have 3
Probos?
space.
Space?
3 space. Yes.
Yes.
And this message have 3 space.
Space is which number?
With 0.
0 number. Oh.
Yes, with
Okay.
0.
Okay, thank you.
For that, in sequence 2, we have 21 numbers.
Yes, I see. Thank you.
With 0.
Thank you.
Yes. Okay. And we have this matrix M. After that, we have to choose an encoding matrix or key matrix. In this case, encoding matrix must be a square matrix with order 3, because matrix M have 3 columns. Let be key matrix this X matrix. No, We multiply message matrix M together with key matrix, and we get the encoded matrix E. We did the calculation with Volta, and after that we have to write this encoded matrix A in the form of numerical or numerical sequence. But if we find these numbers according to module 27, module 27, because the character key have 27 numbers or symbols, we will get sequence 4. Sequence 3 and 4 are not same, but convey the same message. From both sequence is read the same message, which if we turn it into the language of letters using character key in the beginning, we have encoded message. In most case, does not even make sense, this encoded message. And to decode a message, we will need to find the inverse of the key matrix and the character key. The inverse of the encoding matrix X is this matrix with that numbers. And further, it should multiply the encoded matrix E by the inverse of the key matrix, and will take the matrix B, which is same with message matrix M. If we write the sequence 4 in the last slide in the form of a matrix and multiply it by the inverse of key matrix, we will take the matrix A. And you can show that the matrix A and B are not equal. Matrix A and B are not equal, but their elements are equivalent according to module 27. For example, minus 27 is equivalent with 0 according to module 27, or 62 is equivalent with 8 according to the module 27. And this matrix, finally, we write as a sequence of numbers, and we will get the string of numbers 2 that we had in the beginning. And by changing the numbers back to letters using character key, we get the secret message, and all of calculation in this presentation are done with Wolfram. And that was all about application of matrices in cryptography. And now my colleague Mirta will continue the presentation. Thank you for your attention.
Good afternoon, everyone. I am Mirta Azire, and I will continue our presentation for the application of matrices in 3D graphics. So the big question is why matrices and what is their relationship with 3D graphics? I believe it all happens to all of us. While watching your favorite television show, a lot of advertisements probably pop up during those little commercial breaks. Whenever we see something snappy, catchy, or clever, we know that a graphic designer was behind that pretty picture print. Someone spent a lot of time trying to figure out the best way to draw our attention using particular image, object, or logo. But I'm sure not all the people know that behind all that good work is also a lot of mathematics applied. So I have attached here a short clip where you can see really nice red color with all these powerful effects of the 3D graphics that is moving in different directions. It's going straight forward, then it turns left, it turns right. So the big question is, how is this done? How is this done? And the answer is that is the magic of matrices. I want to point out that most animated computer games are based on three-dimensional models composed of thousands of tiny primitive triangles, shapes such as triangles, and each vertex in the model is encoded as a vector. So matrices are a major mathematic tool to construct and manipulate a realistic animation of a polygonal figure. Examples of matrix operations include translation, rotation, and scaling. In this presentation, we will show how matrices are used to transform these vectors in three-dimensional space. We will show also how we will show some new types of transformation matrix. So translation matrix, scaling matrix, and three variation of the rotation matrix. With this presentation, we aim to show how a single transformation matrix can be composed from several transformation matrices by calculating their dot product to create a single transformation matrix that encodes multiple 3D transformation at once. To do that, we'll start this short presentation by giving some basic concepts of scale, rotation, and translation. And we all know that to scale a vector A by a factor alpha, all we have to do is multiply each coordinate with the vector, each coordinate of the vector by the scale factor alpha. Then if we want to translate the vector, let's say h units in the x dimension, k units in the y dimension, all we need to do is just add to the coordinates of the vector these units h and k. And when we go to rotating the vector with respect the origin, is not as simple as scale and translate operations. Here, using trigonometric identities and Ptolemy's sum and difference formulas, we can generate the matrix here that helps to calculate the rotation. So let's suppose I would like to rotate a vector xy by beta degrees counterclockwise. Then we multiply that vector with this matrix here. Now I would like to go back to scale one more time. And I want to point out that instead of multiplying the vector by scaling factor, we can perform the same operation using scaling matrix, like here. I know this gives the idea or the impression of complicating the calculations unnecessarily, but it has some huge advantages. And I would like to show that, let's suppose that I have to rotate a vector through 180 degrees and scale it by a factor of 3 in just one operation. I would first generate the matrix that rotates the vector through 180 degrees. Then I will generate the matrix that scales the vector by factor 3, and multiplying them will give us a new matrix that encodes both transformations. And the good news is that this technique can be applied or used to combine any number of different transformations into a single matrix. It can be noticed that to perform translation, matrix addition is carried out, while to perform other transformations, you saw that only matrix multiplication is carried out. Now, in order to complete all transformation in the same way, so to reduce them to matrix multiplication, homogeneous coordinates need to be introduced. Each original vector xy is given an additional component, the number 1. These extra components have nothing to do with spatial coordinates of the vector. These are still vectors of the two-dimensional space. To translate the vector A, h units in the x dimension and k units in the y dimension, we just multiply the given vector by the homogeneous translation matrix. That is this one with some extra zeros and ones. So same result will be generated. And now to allow scaling and rotation matrix to combine with translation matrix, we need to do some changes to convert them to homogeneous matrices. And now they are here. So again, added some zeros and ones. And here we have homogeneous scaling matrix, homogeneous rotation matrix. Now with these changes or with these modifications, we will be able to conduct any number of different transformations by multiplying individual transformation matrices together, and after that, only one matrix operation can be applied to all vectors of the model. Same as in two-dimensional space, any three-dimensional vertex is encoded as a vector. Vertex is encoded as a vector in this form here. And then homogeneous translation matrix is this one. Homogeneous scaling matrix is this one. And while in 2D, rotation was done in respect to the origin, in 3D, we have three separate rotation matrices, depending on the axis of rotation, X, Y, or Z. For X, so if the angle of rotation is the X-axis, we have this one here. If Y-axis, we have this one here. And if rotation is around the Z-axis, we have this matrix here. Now I would like to see how this is applied on solving an exact example. So let's have a triangle in 3 dimensions with vertices 1, 3, 4, 3, 2, 1, and 4, 2, 2. And suppose we want to rotate through 90 degrees around the y-axis, 45 degrees around the z-axis, and we want to translate each vector 4 units in the x dimension or direction, sorry, and 3 units in the z direction. First thing that we will do is we will generate transformation matrices. So this one is a rotation around the y-axis for 90 degrees, rotation around the z-axis for 45 degrees, and translation matrix 4 units in the x direction, 3 units in the z direction. We are going to work only with first vector, and then the same procedure is applied for all of them. And now the idea is, instead of multiplying each 3 transformation matrices one by one to all these vectors, so if we're working with vector A, instead of multiplying this matrix here, R sub 90, with A, and get the vector that is translated 90, that is rotated 90 degrees around the y-axis, and then the get it result multiplied with R sub 45 to rotate that new vector for 45 degrees around the z-axis, and in the end multiply again with T matrix, that is to translate the new vector 4 units in the x direction and 3 units in the z direction. We can do all of this just by multiplying transformation matrices together and end up with only one matrix transformation. We need to be careful here, since multiplication of matrices is not commutative, so the order that we multiply matrices is very important. So if I want to implement the above given transformation over the vector A, this one here, 1, 3, 4, 1, it could be calculated in this way. So I multiply T matrix with M45, M90, and then the A vector. So here I will give F, the final matrix that I get. And then next here I have shown how I can get all translated vectors rotated by 90 and 45 just by multiplying each vector by this matrix. Also here I want to mention that all the calculations were done using Wolfram, and using Wolfram I also generated these pictures where I see the original triangle is this green one here, and then if I rotate for 90 degrees around the y-axis, I get the blue one. And then if the blue triangle is rotated for 45 degrees around the z-axis, I get the red one, red triangle. And then if I want to translate if I translate actually the red one 4 units in the x direction and 3 units in the z direction, I end up with a yellow one. So this is how it would be done if we do it step by step. But now if we apply the technique that we try to explain today, we would get from the original one in the last one with just one step. So this is all we have prepared for the application of matrices in these two areas. I would like to thank all of you for your attention, and if you have any questions, please feel free to ask.
Thank you, Lahay. Thank you, Haziri. A very interesting application of the matrices operations. I remember like this example that the picture looking at the right side by matrix operation can be look at the left side symmetrically by matrix operation like you presented us. Can you say some application of matrix operation in game theory that just games, for example, games for mobile phones or computer games. Do you know some applications of matrix operations?
I don't know. In this way, I don't see something.
Yeah, I think it is very modern, yeah, very modern application of matrices.
Yeah.
Okay, thank you very much. I wish you and your student good luck. And any questions do you have?
Thank you very much for your presentation. A small question regarding the graphics. So I'm trying to understand the relationship between the mathematics and the application. And when you showed the homogeneous coordinate system, you showed it as a technical trick for performing calculations. But of course, in more advanced mathematics, the homogeneous coordinate system is in fact belongs to the theory of projective geometry. And there is some more sophisticated mathematics going on in the background. Do you see some potential for having a richer interaction, and once we have the homogeneous coordinates as a technical object, to go deeper into the mathematics and to understand the idea of points at infinity and so on? Or is this beyond the scope of your suggestion?
Hi, everyone. Yes, I have done research on that, and I have seen that it may be somehow maybe a hint for all researchers out there to try to think maybe how would be a 4-dimensional space converted in 3 or 3 in 4-dimensional space. Maybe this can open an area for researchers out there.
Hello, thank you for your talk. More than a question, I was thinking an answer to the question of our chairman. All the machine learning theory, deep learning, is strongly related with linear algebra. And for me, has been very inspiring in order to present to the student a modern application of mathematics. And when you say, here in this meeting, we have several talks that say, if you say in the classroom, artificial intelligence, everybody stand up and say, so any video game that is proposing use an option and so is doing artificial intelligence. So you can prepare this answer for the next time when the people say, do you have, yes, artificial intelligence. That is crowded full of linear algebra operation and so. Okay, so is the 21st century answer for everything? Artificial intelligence contains everything. Thank you.
Yes.
questions? Okay, then. Thank you again.
Okay,
Good luck.
is it possible?
Okay.
One moment, please.
Yes, yes, yes. You have a time.
I would like to thank once again all the participants in this symposium for their good presentation. And especially, I like to thank Lauren with her very good presentation in the topic of real life problems, and Vesna Dimitrova from North Macedonia for her very good and very interesting presentation in the topic of using technologies in teaching and learning math. And especially, I like to thank Professor Rodrigo with his very good comments for almost all presentation that I could see. And I really hope that project ITM will continue. But we have a very good experiences from ITM project, and especially in 2 points. How to apply math in real life problems to solve different problems, and how to using technologies in teaching and learning math. Thank you very much.
Thank you too again.
Thank you.
Our next talk related to the teaching mathematics with hybrid platform of Key AI, just Karshi Engineering Economics Institute. The speakers are Jawahar Ishankulov and Alisher Hazratov. The next 40 minutes for you, please. You can begin.
Thank you. Thank you for giving us the chance to present our talk on the subject teaching mathematics with hybrid platforms of Karshi Engineering Economics Institute. Me and Jawahar Ishankulov, we prepared this talk, and making sure. Let's begin. I wanted, at the beginning of my talk, I'm going to cover about the general information and general information and capabilities of Moodle and HAMS platforms currently we use in Karshi Engineering Economics Institute. and challenges on teaching mathematics with those hybrid platforms. And then we have some suggestions how to modify our syllabuses depending on the needs of various engineering specialties. Oh. At the beginning, I wanted to give you one example of use of math in science. And just to avoid giving long references at the end, I just gave the put the preface of this book that I borrowed this example. In 1971, one of the big names in civil engineering, Hans Albert Einstein, spoke about the benefits of teaching probability to children. When he was 10 years old, in 1914, his father, Albert Einstein, asked about some simple questions and just gave him one problem about that questions. And how long will it take till the ground is wet if it rains at the rate of 10 millimeter per hour? Just take your time in finding out. After some considerations, and he gave them, Albert Einstein gave him the intensity, and then gave him that he assuming circles of being wet from every drop is kind of 10 millimeter circles, and then after a few minutes or 1 hour, and then Hans Albert Einstein came to his father and proudly showed the results of he had done the simple calculations, and he just divided the one square meters of area to the circles of the drops. And then the feedback from the big Einstein was, that's all very nice, but it's not what I asked you. I asked you how long it takes to wet the area, how long it takes a given amount of rain to fall. You see, if we take the instant when half the area is wet, where will the next drop fall? Are you sure it will hit a dry spot and wet another 10 millimeter circle? That was the moment when Hans Albert Einstein learned about the probability. And then after 36 years, Hans Albert Einstein published his method, world famous method of bedlot sediment transport method of based on the probability of jumping of bedlot particles given at a given sediment and flow characteristics. So it took about 36 years to Hans Albert Einstein to successfully implement one probability in the science. So I just mentioned it. I will give you the time, and I want you to think about the relationships about the science and math, and then I want to continue with our hybrid platforms. This is the main menu of HAMS that we are using for the second and third and fourth year of students. No, I'm sorry. We recently started using it for first-year students. It's a totally new platform, hybrid platform. We have been using the Moodle platform, other second, third, and fourth-year students now. And then main menu looks like, here you can see the attendance journal and then the timetable and then training list and exams and everything. And then on the left, there is a main menu. The teacher's menu it is. So apart from the education process, the teacher can add his research output to that science sub-menu. So the teacher timetable looks like this. And January, it's and another view of this teacher training list looks like this. Here you can see the education year and then a semester and groups and then lessons date. And for each class there appears one there appears one row. Here you can see the training tab. It can be lecture, or practical exercise, etc. And the lesson time, and then the auditorium in which, and then and the teacher's name. You can see that here. So this HAMS platform doesn't only limit with the providing materials to the students. It also can kind of manage the whole education process related to outside of classroom. So here you can see the attendance journal. So in each class, the teacher gives some kind of, in all universities, kind of coming to university is kind of compulsory. So here this is attendance journal of students. So teacher kind of monitors who is coming and who is not. And then if you kind of if a student misses 3 or 4 pair of classes, and then it will kind of disappears from the HAMS platform, and he has to kind of give the reasons to the faculty why he's not showing up in the classes. So this is a grading list. Looks like here you can see the first. The first column is for marks for the ranking for the scores of the students' performance during the courses, during the classes, and the second column is the midterm exam results, and then they together will be 55% of the whole score, and then the big test at the end of the final exam covers the last portion of the, and then at the end depending on these scores, and then this HAMS platform automatically kind of manages, and then and you can download the PDF and then version of this grading list, and then you will just you can give to the faculty this grading list. So this is the exams list. So here is the teacher kind of manage the exams, and then you can create exam for different courses. For example, you can teach the math to different various engineering fields. So depending, and then you will create the exam and you will upload the tests to that, and then you will fix the date, and you will give the time period in which student has to kind of solve these tests. So these are the topics and resources. Here you can see the topics, a list of topics, and at the left hand, and then here you can see how many resources added, and you can add you can add resources as much as you can. Here are the exam questions, and then here you can see on the right you can make it activated or not, and then you can see review the questions. If it doesn't look good, and you can decide inactivate these questions, and then test of the test content in HAMS looks like. However, it looks nice, but here is some difficulties related to entering these questions to HAMS, and to both actually. To HAMS, it's purely technical issues, and it doesn't get. There are difficulties related to the entering equations to both platforms. So here is math. I don't talk much about the Moodle, so everyone else here apparently knows about Moodle, and then use Moodle. So here is the math course, how it looks like in Moodle in our platform. So we upload the teaching materials and then the tests and everything, and then Moodle can do lots of things. But the main difference between the Moodle and the HAMS is the HAMS kind of manage the whole education process related to it has broader options of managing the whole education process outside of the classroom. Here the test, how it looks like in math, and then next please. Let's come to our first question, and how and what to teach in math. And at ancient times in Central Asia, students were trained more individually than a group teaching. Students preferred voluntary social confinement to avoid distraction. So most of the times they learned subjects in clusters. So they have been taught, they were taught kind of subjects related to each other. So the student can achieve and can do something practical. For example, they have been taught math and the related things at once. And then after absorbing all the knowledge of that teacher, the teacher directed a student to another better teacher, most of the time to other cities. And then that was a kind of education system looked like. And then there was relationships between the apprentice and between the teacher and apprentice. So these teacher-apprentice traditions still exist in craftsmanship. And then on the right hand, you can see the 18mar22 in Bukhara, and so the different sections is for 1 or 2 people looked like in 1,000 years ago. So I want to show you how this teaching changed throughout the whole period. So the traditional teaching, how can how we are taught in universities, and I mean our generation. So being in an offline class means that students made dedication, separating time and attention to education. So there is an increased, however, distance between teachers and students compared to personalized teaching, however. So the other issue is currently there are big divisions between the disciplines. So as a result, there are interdisciplinary knowledge gaps in science. Learning math became a burden to students in engineering fields, seemingly disconnected from their specialties. This is offline, and then so the next, please. So the now, because of COVID and the student-centered teaching, and then hybrid teaching became today's reality. So the every time we teach, we are recorded, and then this uploaded to the platforms. So the student universities are showing greater flexibility to students' time and to students' dedication. So the nowadays students don't have to attend classes anymore. They can just watch the recorded class later when they have time. So so it's some things are changing in education process, as you can see. So internet is enabling this hybrid teaching. However, at the same time, internet, namely social media platforms, Facebook, TikTok, and other ones, they are kind of at the same time distracting students from education. That means today's math teacher also has to compete with those powerful social media sites for students' attention. This is okay. So today science is losing brilliant graduates to industry. And when you ask brilliant and bachelor graduates, undergraduate students who are graduating, and then where are you going to work, for example, in the future? Most of the students in US and in some developed countries, and they are saying that we want to go to industry because they want to get a high-paid, well-paid job. So at the same time gap between the time students taught math and students taught numerical modeling and modeling techniques in engineering in their own specialty discipline. These are very big, 2 to 3 years time gap, and then this is lowering the motivation in students to study pure math. So who we are teaching now? Is it students, future average engineers who work in an industry and who doesn't care about any creative thing, and then or future scientists that change the industry, or maybe we are just teaching the future math teachers, maybe, and then the answers of these questions give us assumption. Who should decide what topics should be covered to how extent in math curricula? In my opinion, scientists who are doing cutting-edge science to solve the problems of engineering and technology should decide what topics should be taught more in math, in engineering specialties. And thinking about that, we have just analyzed 100 research outputs of civil engineering in civil engineer field. From them, 60 a majority of them, and then 63 of them, no, it's not showing the figures. Okay, 63 of them are using numerical modeling and different modeling technologies, techniques, and then math tools in their research and in their studies. And then about 30 of them are using, is just analyzing the current experimental and field data in civil engineering. And about 3 of them are using the reference managers just to write this article. And the other 4 of them are other types. So from the, as you can see, most of them, most of the cutting edge research is being done with the help of math, with the help of modeling techniques, and we just gave some commonly used modeling techniques in engineering, in civil engineering. For example, the regression analysis, dimensional analysis, and then finite volume and finite difference method, and curve fitting optimization, and many, many others. So the conclusion is how can we kind of link these modeling techniques and then with the math, and then there are in my thinking is there are 2 ways of teaching math. One is just forcing them to learn, either or economically or bureaucratically or anything, just forcing them, and then just threatening them with exams. The other one is encouraging. So the encouraging, in my opinion, can be in 2 ways. The first, and through the hybrid platforms. Next, please. So how a successful hybrid teaching platform should provide the teaching material. In my opinion, it's my first personal opinion, the gamification of the whole education process, of the whole course, in which you get imaginary levels, such as Genus level 1, Einstein level, Euler level, Laplace level, etc. And stars, discounts, cashbacks, as those companies which we are competing with, such as Facebook doing, such as Google Map is doing this, we have to do the same thing, maybe. We have to create those. We have to include some gamification in our hybrid platforms, apart from the official scores, and then maybe we can recognize these results or levels in the future when there are some entry requirements of graduate level. Maybe we can kind of recognize it if we can manage the assess the students' performance fairly and fairly manner. And then here is I gave the Super Mario, and then at the right hand there is a Google Map, and someone called. I just borrowed them, both of them, from the Google. The Taxina, someone. They just he has been given the local guide level 10. It looks. It gives students a sense of achievement. For example, when I was studying English, the English teacher were giving us dollars. It's kind of dollars of that training center. So at the end of 2 months, we were kind of using these dollars to buy some actual things. So whoever is richer, it means, so it gives kind of sense of competition between the students and gives a sense of achievement to students. Another one is, the second proposition is visualization of a teaching material. Every topic's material should be given with a solution of a real-life problem of an engineering field. Success stories of someone. At the right hand, I have given someone named Meshkolava, who is big names in civil engineering. His methods are still used in many countries in civil engineering. So I have given this boring table with his image, and then I gave the small who is this guy, and then I'm giving this famous scientist respect, and at the same time people now, students who just learned that table, they will just remember this table relating with this picture, and I can give some success stories how this table is made with the help of something. So the short biography and success story or image of the author of an actuation or method to make the topic more interesting would be a nice thing, in my opinion. Thank you very much.
Thank you a lot, Al-Shiraka, for very interesting informations for us. Do you have any questions, suggestions, comments, maybe?
Thank you. Can I ask something? You used your LMS, the platform that you are using?
Sorry?
The Moodle platform that you are using?
HAMS?
Yes.
Yes, we use HAMS, yes.
Are you extracting any data from the students that they participate in your first year math courses in order to identify weaknesses, commitment, or how can you address weaknesses that the students face? If yes, which kind of characteristics did you mine?
Let me translate this to Jawahar Ishankoyev, the co-author of this presentation. Please come. أنا هذا برنش كورس ده ماتريال ده شو نمانا إشتاتيز ما نمانا نسوي سؤال شو student لنا وزلاشترش باش كتمل لما خندي تحصل كل ده خامسته. So the advantages of HAMS, how it kind of changed the students' performance. You're asking this question?
No. I mean, if you are mining any data, any learning analytics of the platform regarding the performance and the commitment of each one of the students that they participate in the course, and if yes, which kind of, what do you monitor?
ولا أنا student لأنا perform أنا خندي وزلاشترش نقطة أنا زبطان. So the answer was it's a totally new thing. So you can monitor many things with HAMS, and then you can monitor their attendance, and then you can monitor their, you can put questions for every topic, and then you can of course get the data from this, and then okay, understood. Yeah.
Okay. No, just from curiosity, I would like to ask them if they monitor, what do they monitor? Because I'm
Ya o mas qanday o o'shani u studentni o'zlashtirishini qanday monitor qilib borasiz deb student. So for every topic you will add the questions, and then depending on the of their how did they studied, and depending on their study of that topic, they can they can earn they can get scores for each topic and so on. So middle joriy nazorat necha foiz? Necha foiz joriy nazorat? Yo, joriy bilan joriylik bilan oralig'i 55. So they will get score from the 1 to 5 for each. For each topic, and then with the middle exam, and of those scores, it will give us 55% of the total score, and then of course at the same time every teacher can do their syllabuses. How do they manage, for example, how do they assess the assessment of for example, the mine is totally different, and
thank you.
So when I teach that solving like these problems before deadline, when I submit the assignments or some homeworks, I will check. I will fix some days working with students. I will check every work that say how they learn, how they and for estimate their knowledge. I take into their activeness during the class also, their attachment also, and everything I will take into, and I will put the maximal balls, for example, from 5 to 10, and then they will scan it and submit to the platform. This is, I think, the best way for me solving like these problems. Yeah.
And listening the whole week, your presentations, all the presentations, like how to make mathematics like more friendly, more entertainment. I have never listened anyone to introduce, for example, the history of mathematics during this kind of presentation. I think I'm doing this in physics, and this helps the students to feel more familiar with the topic and feel more friendly. But we have here the experts from the pedagogy. If teaching somehow the history of mathematics to our students, that it helps to become more friendly topic for them and approach it with less fear.
Yeah.
If you listen, why I'm asking this? If you listen, scientists that they know very well their disciplines, their presentation starts as following. This guy did this, this guy did this, and then this guy did this, and I'm doing this. So it seems that if you are within the topic and you're feeling familiar or friendly with the topic, you know the story.
There is some very interesting research on how history of mathematics can be used as a pedagogical vehicle. We've heard in these last few days that there might be some emotional advantage to say, it took mathematicians 300 years to understand this, so it's okay if it takes you one semester. But there are some deeper affordances to help get a deeper understanding, cognitive understanding of topics. So yes, it is a vehicle, and not only affective, not only for the emotional
but to make it more friendly, more human, the topic?
Maybe. I don't know. I don't know research that makes this claim, but I think it makes sense. Yeah. I can discuss with Abraham Arcani.
And I'm telling you, I'm motivated by this because always when I'm in conferences in my topic, I really admire the people that, they drive the technology. How comfortable do they feel about what has happened from the past towards the future? So engage everyone, to the discussion and, we follow somehow easier what is happening.
Costas?
One example that I like very much is studying some correspondences between mathematicians. Before calculus analysis was formalized, and following the definition of continuity, for example, and seeing how some very, very strong mathematicians missed the nuance between continuous and uniformly continuous. So there is some potential here.
Costas, first of all, we are doing this, and we didn't present it here because it wasn't. We had other things to present. But for example, when we speak about complex numbers, so we begin the discussion by discussing what is a number. And we are trying to show that, for example, negative numbers were not numbers. I mean, students are used to negative numbers, but until the Middle Ages, nobody thought about negative numbers as numbers. And we talk about we talk about zero and the fact that the way you write, the way you present numbers changes the perception of what you can do with numbers. So we do that. We also do that when we talk about the history of, for example, when we talk about the differential calculus theorems. This is a place where it begs to use the history because you can't find, or at least I can't say you can't. It's very difficult to find a real-life problem to the first and second Weierstrass theorem. But if you tell it as a story of how it was developed, it makes sense. But I think that we don't have, unfortunately, we have very limited time. So we need to choose our examples and our stories so that they will be most interesting to the students. And history is relevant to certain topics, while real-life problems is more interesting in other topics. So we have time to use it in a very limited scale. If we had more time, obviously, I mean, it's very interesting because the way the way the mind thinks about things, the way our collective mind is limited by our perception, is something that is very interesting for students to see. And once they realize that, it really blows their mind. But again, you can do that to a very certain degree in the limited amount of time we have.
using this opportunity, I would like to talk that yesterday I told about Muhammad Al-Kharazmi. He entered the zero to the numbers from 1 to 9, which is called the Indian numbers, and so all the numbers become the easier to write and to understand. This is also the history of mathematics.
Costas, I totally agree with Nisin. No. I mean, I continue his speech saying that you have to select. Okay, I have the opportunity to teach I have mentioned before, to teach to primary school teachers. And we include, when we teach the mathematics, in every chapter, in every history. We don't ask in exams. But I use this in order to promote some idea, more general idea to our students that will be in the future primary school teachers. You have to be a literacy person, a culture person. You are going to be the first person to meet kids. And you feel the first reference as a culture person. You have to be culture. And when I open, you give some reference to history of mathematics, okay, at the end, the program at the end is probabilistic. And as we used to say, this is the last chapter of the program of the subject. Probabilistic is in the curriculum of primary school, and it has been developed finally in the 50s by Kolmogorov, 20th century, picture in colors, people, the prices of Kolmogorov are well known for everybody. In that moment, you explain to the people the history of monkey. And I used to open Wikipedia and show the century that result was related. At the same time that this mathematical result was discovered, Beethoven composed 7 symphonies. Brahms or some picture was drawn, whatever. I try to relate with the whole history of the world. That is another way to connect the mathematics. Say that what happened at that time. At the time that Laplace was developing the first probabilities or whatever geometry by Descartes, you can show what's happening in Europe, the big fever, whatever. That is the way to put in dimension. Oh, I have listened about that in another subject, and mathematics was at the same time working. You have to explain that Leibniz and Newton didn't have email, WhatsApp, but there was a big controversy about that. In that moment, you can call. That's flashish.
But this is very important, even in the marketing theory.
Yes.
If we would like someone to be convinced and buy and adapt your technology, you should say to them, you should sell the topic before you implement.
In general, we talk later we talk in private that the best professor has to be a storyteller. A storyteller don't means everything talking about nothing interesting. Storytelling means you have a complete discuss about what are you talking about. Okay, they recognize that you are a person that know about what you're talking about and have the possibility to be accessible, of course, okay? But not only, my final comment, not only story of mathematics, a story about everything. In order to connect with that, you know what happened, you know how difficult was this, you know how time delay to appear the zero, how time delay to appear the complex number. We are now to dedicate only 2 weeks, but they take 5 centuries to discover this. This kind of example give to the people. You are not going to convince to all the classroom. With this shot, you are only trying to find some Dianas, but you find 3, 4 students that are interested in this. And another 5 or 6 students are interested when you say video games. And another interesting when you talk about climate change, for example, whatever. You have to be all the time sending message. The same that you do with your kids. It's the same.
Thank you. Yeah, I think that each topic which we are teaching at the universities, at least 200 years ago has the history, right? Each topic. So more than, at least, yeah, at least there. So I think at the beginning of each lecture, the teachers should give the historical information. It will be very useful, I think.
I just briefly will add that what said Nassim, the same we are doing, and the way some of these historical significant points concerning math appear, that it's what was first, was it a matrix or a determinant? Was the first derivative, and then the integral was here the first indefinite integral or the definite one, or who invented or who proved the L'Hopital's rule. And these are questions I pass them, and they are sometimes asked to answer it, and sometimes we discuss. And also, when teaching math software, it's also a very long history, even though from 1960s, like, so it is very interesting how the software, for instance, MATLAB, has been developing and then splitting.
I would like to concur with everything you said, and I will.
What does it mean concur?
Concur, agree.
Ah, thank you.
I would like to. Yeah, I would like to concur with everything. Yeah, yeah. Just I would like to. Yeah. Sorry. Well, you can try me. So first thing, mathematics, as I see it, has the same problem that has history. History is usually taught by facts. Learn the numbers, learn the years, learn what happened when, how. The most thing that I have learned.
Comment on this?
Yes?
History is made by the winners.
Exactly. I'm not talking about the content of the history. I'm talking about the way that history is taught. So, for example, history has the same problem because at least in my country, history was taught like, learn this happened then, this happened then, this happened then. This is the same like mathematics. Let's start with this leads to this leads to this. And you know what? I don't remember anything about history anymore. The problem is there is a YouTube channel, Extra History. It's a small doodles about people that do something. I discovered that like 2 years ago. It like has around 200 videos or something like that. There's each like 5 minutes long. I learned more from those Extra History videos that are 5 minutes long in the previous 2 years that I think that I learned anywhere, and I won't forget them. That's the most interesting part. So we have one dilemma, and this is my opinion. Maybe you can disagree with it. We cannot put every student in the same basket. We can try to teach someone the history, and we can try to teach someone the facts. The people that are more interested in the history will try to teach it as a history. We have to have multiple approaches to teach the same problem. That's how it's done. The best way that I have learned about this is when I teach computer graphics. I tell them, okay, here's the mathematics, here's how it came to it, because computer graphics has a lot of mathematics. I'll say, this is how it came to it. If you want to learn more, go watch 2 blue, 3 blue, 1 brown to learn about how linear algebra is transforming the space inside. So the students that want to go through the material, okay, they can listen to my talk. If they want to learn something more and get in depth with it, they can acquire 2 extra sources. So that is.
Okay, if you want somebody who disagrees, you always have me. I mean, you know, in Eastern Europe, we had that saying, I have my opinion, but I disagree with it. So there is a fantastic professor my age called Eric Lander. He's professor of MIT, and he is mathematician by basic education. Such a high school prodigy, he was on mathematics Olympiad when he was high school student, graduated mathematics, got PhD in mathematics, and then he said, well, I don't want to spend my life teaching somebody about something that old guys with white beard who are dead for more 200 years did once. How is that relevant? I want to do something that happens now. So he became one of heads of Human Genome Project, and now he's fantastic professor of biology. I took his biology course on edX, and that's the most brilliant teaching ever. And sometimes he just comes and says, I'm coming from a meeting and I'm going to tell you discovery that was published this morning. So what I want to say, as I told you, I have my opinion, but I disagree with it. I agree with what you said. But we should, with all those historical stories, be very careful to put relevance of that for nowadays young people. Newton and Leibniz invented that calculus 2, 3, 4, 500 years ago, whenever that was. But I mean, what is in that for me, thinks nowadays young person? Why should I care about what they did 400 years ago? How is that relevant for me now? And I mean, all other courses, political science, economy, biology for that sake, they're talking about things happening now. And we are talking dead, old guys. Sorry, we need to be interesting.
Yeah, but you are now expressing the same thing. You are expressing how to teach history and how to teach math. I'm telling you to do how to teach history in an appropriate way, not just, reporting facts. And you can link, these facts with what's happening right now, the impact of its inventions now. Okay, so it's how to teach history, how to teach math, how to teach physics, not, just to report facts and report results. I'm telling you, if you read, I'm a laser physicist, so my PhD is in lasers. So if you read the book, how the lasers have been invented, I mean, you're not laser physicists to be able to convince you, it's like a way of thinking how you should think in order to advance what's happened by following the steps of other people, not, I mean, the steps, the way, how did they examine, what did they examine, and how did they perform.
I just wanted to say that I don't disagree with what Olga said, and I think that this is the way we should talk about history. So, for example, when we talk about complex numbers, we do that in the context of why people, what was the need? How does our mind limits us? So this is just an example of what happens to us today. And also, what we also do in complex number, we tell them, okay, so we invent, let's invent that there is a solution to a square minus 1, and this is I. You can do that? Yes, I can. Why not? I can do that? Yes, you can. You can do whatever you want. So I can invent whatever I want? No, you have to be consistent with what happens, and I'll show you. So this is an opportunity to teach them how math develops and what is allowed and what is not allowed. And this is usually becomes very relevant to them. And also another interesting fact is why negative numbers were invented and why 0 was invented. And the reason was not because there was a need. Because I give them the I usually show them the Roman system, and I'm doing an addition, and this is very easy, and then I'm doing a multiplication or a division, and I tell them, good luck to you, you want to do that? And they said, how did they survive? And I tell them, the fact is that they survived. They had an empire for 1,000 years with these numbers. So how did they survive? They survived. So why to change? And usually the change in the cultures that zero was invented, the reason was mostly religious, because they were interested in large numbers or small numbers, and then you cannot use, and then all the disadvantages of the Roman system or systems like the Roman system come into play. And then suddenly you see that they're beginning to think about what happens in their lives in our situation, because we are also limited to our culture. And once you do that, they're very engaged in the lecture. And this is lecture about complex numbers and about math. So they're very engaged, and again, continuing what Olga said, the idea is not only to show math, to show history, or to show math, but to show how this is relevant, or how this thinking affects the lives today, or how it affects the thinking today.
Okay, more questions? Okay, thank you, Al-Shiraka, again. So we have again the coffee break time till 5 p.m. Yeah, this is the last one. Thank you, all speakers. We will soon.
Muchas gracias.
I'll just so. Oh, where do you put it here? Yeah.
Γεια σου Μανώλης.
Hello.
Hello. All right. Are you going to introduce him?
Yeah.
Manolis Lourakis, eh?
Manolis Lourakis. Hello, nice to meet you.
Hello.
I can introduce him.
Okay, okay.
But you are going to introduce Mr. Cooper.
Okay.
Thank you. Should we start? Yes, we will wait. We should wait. Did you try to share your screen?
Yes, but you know my problem. What is I have multiple screens, so I don't know actually what screen is going to be shared.
So yeah, make an attempt before they come.
Make
a trial.
Because I am unfamiliar with Google Meet, I press what says as so. Okay. So what do you see now?
Nothing, yourself.
Okay, I don't know how to share.
I think that you should go to the arrow, no? There
Yes,
is an arrow. Press the arrow.
Yes, I pressed it, but...
Or press the... Do you know how to use the Google Meet? Yes, this one. The whole. So, Manolis, you will go to... Θα πας στο βελάκι που έχει και θα πατήσεις τι θες να κάνει να μοιραστείς. Ή όλη την οθόνη ή δύο... Πήγαινες να μοιραστείς όλη την οθόνη. Έχει, δίπλα στο χεράκι έχει ένα βελάκι. Αυτό πατάς.
Το πάτησα αυτό.
Ναι, και τι σου βγάζει. Πρέπει να διαλέξεις τώρα.
Δεν μου βγάλει τίποτα. Έχω μετά 3 εικονίδια.
Do you allow him to share his screen? Yeah, in Zoom, of course, it needs. You should allow him to share his screen. In Zoom, you should allow him. Google Chrome. So all the browsers should work. Manolis, probably you should share the right screen.
Okay, give me 30 seconds, please.
Eh? But I'm explaining him in Greek what he should do. Easier, no? Οπότε άμα πετάς το βαλάκι, τι σου βγάζει, ρε Μανώλη?
Ωραία, πάμε πάλι.
Εδώ δεν μιλάνε και αγγλικά, εδώ είναι...
Τώρα το έχω πατημένο και...
Να το, κοίτα, σου δείχνουνε. Βλέπεις το βελάκι, το βλέπεις δίπλα στο χέρι.
Πρέπει να σηκωθεί η κάμερά σας λίγο πιο ψηλά, γιατί δείχνει το κάτω μέρος της οθόνης σας. Αυτή που είναι πάνω στο έδρανο εκεί μπροστά σου, Κώστα. Έτσι. Ωραία. Το έχω πατήσει αυτό και τώρα είναι γκρίζο, δεν μπορώ να κάνω τίποτα.
It appears to him a gray screen. Manolis, you can send the presentation to us, and then how are you going to do that? He's not here. He can. But it's amazing. I mean, he can share the screen. I mean, it's amazing how the others they manage.
Yeah.
Press it.
Okay, press it.
The second option.
Okay, the second option. Okay.
And now select
The screen that you would like to share.
Yeah, the screen has to be open, no here.
So, Kostas, ask them please.
Yeah.
I have already pressed this button and now it's gray. How do I?
You have to see something like this with all the windows.
Return back.
Cancel it.
You have to see something like this.
You cannot see this thing?
No. And now I cannot get back to without sharing. I have a gray button.
Refresh, they tell me here. I have the presentation.
You are mute.
Yes, Kostas, please, if you can play your copy of the presentation, and I will guide you through, no problem. But your copy doesn't have the videos I would like to share with you, but it's okay. Yes, okay.
So you are going to ask the lady next, and we're going to proceed.
Okay, let's let's hope that it will work because it has a few animations. Okay.
In order to show the animations, should they start? Yeah?
I am ready.
Okay. So we're starting the evening session. We have two contributions, one from the Hellenic Mediterranean University and one from Weizmann, the last one. It's a great pleasure for me to introduce you Manolis Lourakis, a PhD student of mine in pedagogy, in teaching sciences, because my main research is not on this field, but from curiosity, I think that you are doing something very important. Manolis is like an ex-F-16 aviator, so he's a mature student. He's very much interested in how to apply new pedagogies in teaching electronics. So thanks to the item, that one of the main priorities that we have identified is the teamwork, we decided to act in the teamwork and how to make the people to work efficient under time restrictions, more realistic conditions as the market works, and also some tips how the students, not only they are going to work as a teams, but also they are going to become the owner of their learning. So Manolis will show to you some initial results that they are under review for publication regarding the application of the Scrum methodology during COVID-19 in an online course in physics, an introduction to electromagnetism. So this is not the only case that we have applied Scrum, and we have very encouraging results. We have applied also Scrum in real life, not in real life, as a BBL, as a part of BBL. Three Belgium students of mine, they construct an actual device using the Scrum and the principles of the Scrum. We hope also this to be soon released as a publication. So Manolis will show you our initial results, and also to compare with, to show you a comparison, the students that they face, that they follow the Scrum, and the rest of the classroom that did not follow the Scrum, what was the main difference? Of course, you know, the first time that we ran the Scrum, it was optional. Now we try to apply the Scrum for the total population of the same course. So Manolis, the floor is yours. Thank you.
Hello everybody in Tenerife. Thank you for having me here. Thank you, Kostas, for the kind introduction. Let's not waste more time. Next, please. Next. Press 5 times, please, to see the overview. We are going to define Scrum, how it started. We will describe it and some of the details, where it is applied nowadays, and then I will tell you about our experience in Hellenic Mediterranean University. Next. Let's start with a definition. Next. Scrum is not a methodology, it's not a checklist, it's not a list of actions. It's a framework that helps people, teams, and organizations generate value, as it says there, through adaptive solution for complex problems. It's an empirical method. They have tested all the items of Scrum in the past, and they have proved that they work. That's why they implement it on the Scrum framework. Next, please. So, how it started? Next. Everything started with those two gentlemen, Hirotaka Takechi and Ikujiro Nonaka, when they first published in 1986 in Harvard Business Review a study about how to make in the automotive company in Japan the groups of people more efficient and more happy in their work. Next, please. Their work was the stepstone for those two gentlemen, Ken Schwaber on the right and Jeff Sutherland on the left. It was the inspiration for those two gentlemen to write the definitive guide of Scrum, of where I took almost everything in the first portion of my presentation. It's only 13 pages, but it's very well written and very well explained there. In 1995, they came up for the Scrum framework, and we are using right now the 2020 revision. Next. Those two gentlemen, along with the other gentlemen that they are listed on the right column where it says the author, in 2001, and probably you have heard already about that, they signed what it is called the Agile Manifesto. The Agile Manifesto is a set of principles that you can read on the screen that puts individuals, interactions, working software, customer collaboration, and responding to change on top priorities, on the contrast of the following of the traditional waterfall method, where those were not priorities. So we prefer people and interaction over processes and tools. We need to have working software every once in a while, and we shouldn't follow comprehensive documentation, and customer collaboration is a key for an early release of the product. That goes That is the principles of the Agile Manifesto. If you want to elaborate on that, you can read also the 12 principles that lies below these 4 principles. Next, please. Next, we are going to describe in general Scrum has an incremental approach. That means it divides the whole work in small chunks, and by repetition of events, the iterative nature, we can optimize predictability and control risk, so save money. And next, please. And the most important feature is that engages groups of people who collectively have all the skills, cross-functional teams, as we say, and they have all the skills to do the work and share and acquire as needed new skills. That was the sentence that exhilarated us in order to use Scrum in higher education. Next, please. The Scrum stands on 3 pillars: transparency, inspection, adaptation. With transparency, you can have inspection, and by inspection, you can detect early problems and you adapt on those. Next, please. The working team, the people that working on Scrum, they need to have these 5 values. Openness, so to be clear and sincere with everybody in the team. In that order, you gain and give respect to each other. And by respect, you have the courage to speak up your mind. Next, please. And so you can focus and commit to the task. Next. We need to remember that this is a framework. And like a picture frame, you are free to draw everything inside. How do you like inside this picture frame? You are not supposed to violate the boundaries of the 3 pillars, as you can see, and the 5 values. But you can move however and whenever you like inside this frame. Next, please. There are 3 roles, distinct roles in a Scrum framework. We have the product owner, who is totally responsible for the final outcome. We have the Scrum Master, that his job is to apply Scrum as it written in the guide, and the developers, the team that do all the hard work. Next, please. There are five events, the sprint and what lies below them. We are going to explain them in detail in a few seconds. Next, please. And what is produced, it is called the artifact. And we have 3 artifacts: the product backlog, the sprint backlog, and the increments. Let's move on to some details. Next, please. You always need to remember that this is a framework and everything is going round in circles. Next, please. So, few details. When we say transparency as a pillar, we mean that everybody must know what everybody else is doing in the team. And you achieve that with a daily Scrum, which holds the Scrum Master, and it takes only 15 minutes. Probably you have heard that as a stand-up meeting, but the actual name for the Scrum framework is Daily Scrum. Next, please. Inspection means you need frequently to check your product, what you are doing, so to detect any problems early and minimize the risk. And the only thing you need to do to have frequent inspection is to follow the guide for the 5 events of the Scrum. Next, please. And by the previous 2, you can adapt. A very, very key feature of Scrum is that you need to deal with a problem the moment that the problem shows up itself, okay, immediately. So in order to do that, you must be aware. The Scrum team, yes, please, go next. So another very, very important feature of the Scrum framework, it was borrowed by the words of the famous George Patton during World War II, that he said in some battlefield, don't tell your men how to do something. Just tell them what to do and explain them why they need to do it, and they will amaze you. That stands for the Scrum team also. In the Scrum team, we have no hierarchy, there is no leader, and the team is self-managed. And also the team, because it needs to communicate frequently and clearly, it is kept small, under 10 people. The rule of thumb, as it is described in the book from the co-author Jeff Sutherland, is the magic number is 7 plus minus 2 people. Next, please. Let's see the roles now. The product owner, he is responsible for the final outcome. So he needs to do all these things that is written in blue. His most important job is to convey the vision that the stakeholder has about the product to the team. So he is a direct link between the working team and the client that ordered the product, the stakeholder, we can say. Next, please. If you ask a Scrum practitioner who is the most important role in the Scrum framework, he will respond the Scrum Master. He is a true leader that serves the Scrum team and the larger organization. His first duty when Scrum is first applied in some organization is to convince the organization, the administrator of the organization, that Scrum works. And it has proven his worth around the years now, but sometimes he needs to convince the heads of the company that Scrum works. His other important, probably most important job is to apply Scrum as it is written on the definitive guide of Scrum as revised in 2020. He should not deviate from the steps there, from this guide, and his, let's say, latent purpose is to help the team evolve sprint by sprint, working period by working period. Next, please. The developers is the people that do the actual work. Their only responsibility is actually to embrace the 5 values of Scrum and communicate. So with communication, they have transparency, transparency leads to adaptation, and adaptation leads to inspection. So what they do, it's written in those 4 bullets there. They convene with the product owner and the Scrum Master and the stakeholders during the sprint planning to make the product backlog and the sprint backlog. Next, please. So let's go next. There was a video there, but due to the problems, you are not going to see it. In the reference, I have those videos, the URL for the YouTube. They are very, very useful and will help you to understand Scrum in 10 minutes. So what is produced in the Scrum called the artifacts, and we have 3 artifacts. The product backlog, which when it is complete, it will lead to the final product, the product goal. Next, please. A smaller subset of this list of to-do items is the sprint backlog. When it's completed in each sprint, get us to the sprint goal. And also we have the increment, what is produced during each sprint. In details, those items, those increment, those artifacts, the product backlog is a list of requirements for the product. That's all. It is prioritized by the product owner, and every member can add anytime can add an item, because the Scrum is completely dynamic. It's not static. Everything changes constantly. One restriction here, only the product owner has the authority to delete an item after talking with the people. Next, please. The sprint backlog. The sprint backlog is a smaller set of to-do items that it is taken from the big list of to-do items, the product backlog. So it's in a sprint planning meeting, each member of the team picks up a task to do, or 3 or 4 tasks, or they can do what it is called the swarming. So they pick collectively, let's say 5, 6, 10 tasks, and they start working from the top down. The whole team works to the first task until it is completed, and then they move on to the second one, to the third one, until they complete all the items in the sprint backlog. Next, please. In order to have a guide about the deadlines, they can use the burn down chart where in the vertical axis they depict the estimated effort for this period of time, which is called the sprint, and on the horizontal axis you have the calendar days until the end of the sprint. So you can use either hour or points, and points or hours can be derived by the so-called user stories, which is a small role-playing game during the sprint planning meeting. Probably you have heard about user stories and Fibonacci series. Next, please. So the container event is the sprint. Everything happens inside the sprint, which is a default period of time from 1 to 4 weeks. The sprint starts with the sprint planning, where everybody meets, product owner, the client, aka the stakeholders, the Scrum Master and developers, and they listen to the vision of the stakeholder, what needs to be done. So in this sprint planning, they need to devise the sprint backlog, the product backlog. They take a portion of that, and this is the sprint backlog, and each day they work, they have the daily scrums, each working day. At the end of the sprint, they hold the sprint review, where they present their work of value to the stakeholders or the product owner alone, preferably with the stakeholder, because we need his constant feedback. After this meeting, the sprint review, the team holds a special meeting, the sprint retrospective, where they discuss how did they go to during the last sprint. Next, please. So in details, in the sprint planning, the product owner explains why is this sprint valuable, and everybody collectively decides what can we do in this sprint. The team only, not the developer, not the Scrum Master, not the stakeholder, only the developer team will decide how they are going to work. Those events are time frame. If you have the maximum length of the sprint, 1 month sprint, you shouldn't spend more than 8 hours in this meeting. Next, please. In each working day, the Scrum Master enters the working area, preferably the same time every day, and he holds, go back one please, and he holds what it is called the daily Scrum, back one, yes, here, thank you. It is up to 15 minutes. You shouldn't go further than this time, because everything in Scrum falls under the umbrella of lean, without fat. We don't have documents, we don't have Gantt charts, we don't have reports, but we have limited time. So everything must be time frame. So up to 15 minutes, where for start, an inexperienced Scrum Master should at least ask each member of the team those 3 questions. What did you do yesterday? What are you going to do today about the project? And what obstacles are in your way? By that, he achieves transparency. So everybody, their responses, and knows what everybody else is doing about the project. Next, please. So let's say the sprint has ended. We have a working piece of software that needs to be presented to the stakeholders. So we hold a meeting that is called sprint review. And the purpose for this is to inspect what we have done. We need the feedback from the stakeholders. And we see if we have really managed to erase from the board some product backlog items. Next, please. Then the meeting that is called the sprint retrospect is held, and the participants are only the developers teams, the developers and the Scrum Master. And this probably is the most crucial meeting, because the purpose of Scrum is also for the team to evolve sprint by sprint, to get better, faster, more efficient sprint by sprint. In order to do that, they need to have a sincere discussion and honest discussions about how they interacted between each other at the last sprints. What were the processes they used? They were bad, they were good. What to keep, what to discard, and the same applies to the tools. Maximum 3 hours duration for a 4-week sprint. Next, please. Scrum has a great momentum in the industry. Apart from the software development sector, all these sectors using Scrum now. Next, please. And if we go by brand name, all these brand names and corporations, they are using Scrum as we speak. Next, please. In higher education, the past 10, 12 years, there is a trend of applying Scrum in universities. So we have experiments in Spain, University of Malaga, we have in Hong Kong. Next, please. We have alliances that are built on advancing the use of Scrum in higher education. Next, please. Scrum.org is an organization that can help universities incorporate Scrum in their curriculum. Next, please. And high prestigious universities, the Ivy League universities, also thinking of applying Scrum nowadays. Next, please. Next. Next. Also a video here. And let's see the experience in our university. We tried to apply it last semester, which the course was given online due to COVID-19 lockdown. And the great challenge for us was to apply it as it was written in the Scrum guide. I repeat, only 30 pages, crystal clear, plain English, very easy to apply that, in remote teaching conditions. The desired outcome was to learn by their own. If you are teachers and professors in the audience, you know by heart how difficult it is to engage your students, especially in remote teaching conditions, in tele-education, let's say, in remote education. So we thought that Scrum maybe it's a good motivator. It gives the students drive to work forward, a better knowledge practice, a better pedagogy. So we ask for volunteers, and we have students from different semesters. Our secondary aim in this experiment was to enhance their soft skill of communication, collaboration, critical thinking, presenting their work, keeping deadlines, and everything that falls under the umbrella of soft skill. So we had separated the semester in 2 phases. First Scrum and second Scrum. On the first phase, out of the 10 students they presented, they came forward as volunteers. We had 3 teams, 3, and 4 students. And for the second phase, which lasted until the end of the semester, we had only 2 teams for 4 and 5 students respectively, because we have at the middle of the semester 1 dropout, 1 student quitted due to personal reasons. Next, please. So, what was the assignment, the division of the semester? For the first phase of the Scrum, we decided to have 3 sprints of 2 weeks each. So we decided to go into the heart of the sprint period, not 1 week, not 4 weeks, in the middle, 2 weeks, 14 days. And for the second sprint, for the second Scrum, we decided to have only 1 long sprint, 3 weeks duration, to see how do they handle without frequent inspection. Because remember, at the end of each sprint, we have the sprint review. So the product owner, the teacher in our case, Mr. Petridis, who is in the audience, and the Scrum Master, which I was in that particular case, we can see how they are doing. That's why in the second Scrum, we decided to have only 1 sprint, 3 weeks duration, and actually we let them do their own stuff without inspection in between. What we asked from them? We asked from them, as a final product, to present 1 45-minute presentation explaining the function of a device, electronic or electrical device, using concept, laws, and terms from the Physics 2 course, not popular science. Also, the desired increments, so we asked them also at the end of each sprint to present a portion of their work, and that was a 30-minute presentation explaining the items that we're going to see later on in the sprint backlog and how did they understood and learn them. Also, we taught them how to make a burn down chart, and they presented an updated burn down chart in each daily scrum or stand-up meeting. Next. So, because we would like them to learn the learning objectives that they are written already in the Physics 2 curriculum in our university, we gave them a ready-made backlog. In normal Scrum practice in a corporation, for example, the team makes the product backlog. But in our case, because the product is knowledge, and our students were at the same time the stakeholders and the developers team, we gave them a ready-made backlog for the first Scrum, the 21 items you see on your screen. So they are the learning objectives taken out from the textbook, preferably, because they need to have also a reference where to search for those concepts. Next, please. We asked each team to explain the function of the device you see on your screen. Rectifier diode, MOSFET transistor, Faraday's cage, but the definition of done was to use the 21 concept that we saw earlier in the way they understood that. Next, please. For the second Scrum, we would like to compare the performance of two teams, so we asked the two teams to produce the same product. The backlog for the second Scrum had only 8 items, but if you are familiar with physics, you will see that those concepts are much more harder and much more wide than the previous 21 concepts, which were the base of the Physics 2 course. Next, please. So, one of the most important discoveries we made in this experience was that the students, decided by their own to use Discord application for doing all the work. Discord is very popular among the youngsters, teenagers or students. It's a gaming application free of charge, available in any device, and this is an actual, let's say, virtual building. You can build rooms inside of it, and when you have administrator rights, as I did when I was a Scrum Master, you can silently go into the platform, and without annoying anyone, you can see in each room, in each channel, who is working and what they are exchanging. And you can intervene anytime. It has the authority to exchange files, videos, making teleconferences, etc. It's a very, very agile platform. Next, please. For the sprint planning, sprint review meetings, we used the Zoom platform. Next, please. The students by themselves decided to use Microsoft PowerPoint for presenting their work because the majority of them were already familiar with that tool. Next, please. And for the burn down chart, they used Microsoft Excel again because the familiarity they had already with this spreadsheet application. Next, please. And let's come to the positive thing on this experiment. All teams managed to deliver the products on both phases. So we had a total increments of 6 presentations, 30 minutes each. We have 5 products delivered. We have a total of 56 burn down charts. We didn't say how they are going to work. They decided to work on their own time, but they needed to post the times that were working so I can attend the daily Scrum meetings. So by the statistics of this semester, I took out the averages. So all the weeks, all the teams had an average 4 working days per week. And the average duration of each working day was about 2 hours. At this point, I would like to stress that the 10 people that participated in the experiment, they have also the other obligations in the semester, other courses and lessons to attend to. So that was an extra effort for them. That's probably why it may seem to many of you the short period of working time. But as you can see, it was enough. Only one student quit at the end of the sprint 3 of the first Scrum. Next, please. And here is the most positive results on the exams they took, along with the rest of the 92 students that were enrolled in this course. So, out of a total enrolled students 137 that semester, a total of 100 of them participated in the final exams. 8 of them were the people that participated in the Scrum. 5 of them achieved a pass score. In our university, we use the 10-point system. So if you get a 5, that means pass. If you get below 5, it's a fail on the exam. And the most important thing is that those 5 students that passed the final exams, they achieved a score by 8.9 out of 10, where from the rest of the students, no Scrum students, only 31 passed, and their pass score was 6.8. So we think that we saw an improvement on their performance due to the Scrum. Next, please. Here we can see the distribution of the grades with the light, let's say green, this color. We have the people that participated in the Scrum. Yeah, next, please. We also asked for their feedback, how did they feel? How did they perceive the impression they had on Scrum? We had 21 questions, and now I will present you the most important of them. So, in order to get them to the Scrum framework, we gave them 2 different lectures. The first one was the same that you already saw in the first portion of my talk. Okay, and we had also a second lecture explaining the details, the administrative stuff, the sprints, how we are going to work, etc. And as you can see on the graph, more than half of the participants, they thought that it was neither difficult nor easy. It was as expected. That shows us that you can teach Scrum on how to do it, and it is not difficult. We have 1/4 of them that they say that it was easier than they thought, and another quarter that it was harder than they thought. Next, please. Another positive feedback from the students is that they perceived that they learned more. They had more knowledge for the course during the Scrum in comparison if they did the course only by attending the online lectures. The other half, they said more. So much more and more, very, very positive for us. Next, please. About the soft skill enhancement, apart from our opinion, the product owner, Mr. Petridis, the professor, and me as the PhD student and Scrum Master, that we evidented that in each sprint review as the project progressed. They also thought, and it was apparent, I say again, that they enhanced on how to keep deadlines. They got better in communication. They got better to handle the course material, textbooks, sources, etc. They got better on searching the literature, and of course, they got better on presenting their work. Next, please. Let's move on to the other project we did last semester. It was the build of an IoT device. Here I had the product video, but due to the technical problems, you are not going to see it. It was a weather station. Next, please. So that was face-to-face teaching. with 5 students, 4 from Belgium and 1 from Germany. At the spring planning meeting, we saw the available days we had until the end of the semester, this January 2022. So we collectively decide that we are going to divide those periods in 3 sprints of 20 days each. You can see on the slide the calendar days and the duration for each sprint. Next, please. The previous one, this one, thank you. So after the application, they finished, of course, the product, and the product was demonstrated to us in a working condition. So we had actually what it is called a minimum viable product, let's say a prototype, that worked perfectly. All the sensors, the weather, the wind sensor, the rain sensor, the temperature, the pressure, everything, all the data was uploaded to the internet, and we had the authority from our cell phones to control and view this data. That's why we called it Internet of Things device. And after the finish of the project, the statistics showed that those 5 people, one group of 5 people, worked an average 3 days per week, and the average workday duration was 4.8 hours. Next, please. They worked on the campus. In the sprint planning meeting, they had the initially, let's say, the left column of what you are seeing on your screen. That is called the whole product backlog. But as we said, this is a dynamic feature. So by the end of the project, the product backlog grew bigger and bigger, and became, as you can see in the screen, if you can see it because it's too small, I think about 90 so items. So all these tasks were delivered by the students. Next, please. And when we're saying delivered, apart from the functional device that they demonstrated their functionality on me and the product owner, they had also the task to make a user manual and a technical report, which we can say it was a near perfect job. Very, very detailed, very well explained, very nice English. It was an amazing job. Next, please. We asked them also about their feedback. They had participated in the group project in the past. We need to know that to see how did they perceive the Scrum framework. Next, please. And that were the problems they had in previous group works. And because they are students, the most important problem for them, it was that everybody on the team took the same score, even though there are in each team some free riders, lazy people don't work, or some people did all the job. And that's an aspect we are trying to work now on this semester, where we are applying Scrum on the whole enrolled student group, as Kostas said in the introduction. Next, please. So again, the same question. Before the start of the project, I gave them 2 lectures about Scrum. And again, they thought that they understand it pretty good, the majority of them. That's another indication that you can explain Scrum to your students by only referring to the guide. And that's all. 13 pages, that's all. Next, please. Another interesting question. Everybody believed that it was easier than they initially perceived. Because the procedure is very dynamic, it gives freedom to the people to work as they like, doesn't have many documentation. That's why I think they answered that it was easier than it seemed. Next, please. And the usual question about what did they gain from the framework. They got better on keeping deadlines, very crucial in the industry right now. Time management, very crucial soft skill in the industry again, and the rest you can see on this projection. Next, please. So that concludes my talk. We talked about the Scrum definition. We saw how it started. We described it and we saw some details. We saw some application and I explained you the experience we have so far in our university. And at this point, I would like to say, I have 3 minutes left, yes. At this point, I would like to say that right now we have in face-to-face teaching 15 teams of students initially from 7 to 10 people. We have already 2 teams that we have dropouts. So from the initial 134 students, right now they are participating after 1 month of application. And that's probably cost us, you haven't heard because you were absent. So that's new information for you also. So right now we have 13 active teams and we are trying to do Scrum in scale as a mandatory project for the whole semester. So that was all from me. Thank you for your attention. If you have any questions, I am at your disposal. Thank you. Next, please.
Thank you, Manaris, for excellent presentation. Okay. We will be late to begin this presentation, so maybe a few minutes have passed by respect to the table. So, do you have any questions?
Thank you very much. There is something that remained a little bit unclear to me. So in the educational context that you described, what is the Scrum product? And in what sense is it a Scrum, is it genuinely a Scrum product? Because if the product is knowledge, then as opposed to then you want everybody to have the knowledge. It's not like you can delegate. This person is going to know this and this person is... So I don't quite see how it all comes together in the educational context.
So can I answer?
Yes, please.
Yes. As I told in my talk, in Scrum, as we used it in Young University and another university, this is not an original idea from us. So the students are at the same time the clients and the developers. Are we okay with that? They have 2 roles. So, by that, why we say the product is the knowledge? Because our work for this semester was to teach them physics too. Okay? And we decided to do by Scrum by giving them the responsibility of doing so and keeping them accountable for their work, for their kind of work. Because as you probably as educators are familiar, the traditional teaching method, lecturing only, the teacher on the board and the audience, the students, it hasn't much good result nowadays. That's why we tried Scrum. And again, the concept was you have a product backlog, which is the concept of physics. And you need to work in teams in order everybody on the team to learn the items you have on the product backlog. Probably your question is, how did we know that they have learned this? How did they produce knowledge for themselves? Apart from the exam scores we showed you, in every sprint review, the product owner, Mr. Petridis, asked each one of them oral questions, verbal questions about what they have presented us. So he had an initial evaluation about the amount of knowledge they gained and the amount of comprehension they have, which are the basis of the Bloom's taxonomy pyramid. So we thought, okay, if we have that, let's move on the higher scales of the pyramid. Analysis and synthesis. That's why we asked them to move forward to present their work by making a PowerPoint. And when we say synthesis, we went a step forward on creation we didn't tell them how those devices work. And they didn't know that because they had this course is a second semester course. So they didn't know how those devices were working. But they managed to explain how those devices are functional, and they managed to use the concept, terms, and laws of the physics too. That was our evidence that it worked. So again, the product is knowledge, and they produce it by themselves for themselves. I'm not sure if I answered your question. And Mr. Petridis can help because he's in the audience.
Like in mathematics, I think now what we have presented, we are teaching the concepts and we present a real life problem. In our case, you know, the students, they should learn by themselves, like working the team, the items that we have told them. But they should not, during my interviews, I did not ask them what is an electric field. But by combination of all these topics, I would like to explain to me how a transistor works. So through the operation, how they describe the transistor, I would like, or I direct them to show me where is the physics behind the operation of the transistor. If you change one physical parameter, what you expect to present in the active devices. So what I was trying to do is to link physics with electronics, but starting from the real life example to do a reverse engineering, to show me where the physics, how the physics works in a real device.
So I can pinpoint my question. As the product owner,
I was the product owner.
so when do you delete something from the backlog? What is the criteria, your criteria for saying this is completed, I can delete it? Because I remember from the presentation that only you are permitted to delete, yes?
Yes, but you know, before they start, you know, the teamwork. So my criteria was the criteria that I have. What do they have learned? How do they explain my questions based on a real-based device? And also, what do they expect to observe in the laboratory, or what do they expect as a human's critical thinking? If I change this, what it will happen? So the list of the items that, you know, consists this to-do list, you know, it was checked by me. I gave it to them in this case, because in the case of the people on the Belgium, I just told them, I want this device. So the list of the backlog was presented to me as, you know, a plan. How do they achieve this within the time of the time framework that I have set to them? Like in the market, I need something in 2 months. So I'm going to check you what you have done based on your plan in a different period. So the main gain for us, or I think the main gain for us, because they knew what we are doing right now, it will show how it will be applied, because probably these students were going to be the most motivated students. So they are going to do it, you know, in any case, they know how to work, or we think that they know how to work. Now that we apply this and as how can I say, as a mandatory methodology for all the classroom, we are going to have more, you know, I think more clear results. So what we saw is like, personally myself, is like how by learning by themselves, or by designing, you know, the learning pathways by themselves, the impact we had on these numbers, that they are very small, but it's an indication. In the experiment anyhow, what are you doing? You just see in the lab a small flash in order to engineer the whole device.
We have one more question.
Manolis, thank you very much. Very interesting talk, and congratulations on this work. My question is regarding the team formation. For example, the first Scrum result you had was 8 students participated. Okay, who decided on the teams? For example, did you as Scrum Master decide who would go on which team? How were the teams distributed, or the students decided? Because there were 3 students that didn't pass. No, they failed.
Yes.
Were these students, did they gather in one team? So they had no help from the strong students, were the weak students that, and another question which is related is, wouldn't you expect that all of these 8 students would pass because they had presentations, they had questions from their teacher during the semester? Why did these students fail? Was this to do with teams or what? They're two different questions, but I think they're related. Thank you.
Yes, yes, of course. So let's go to the first question. Do you hear me clearly?
Yes.
Okay. About the first question, the team formation. In the very first Scrum last year, with initially 10 students, we decided to mix the experiences. You know very well that in Greek universities, you have the, let's say, the choice to skip a class, and even if you are in the 10th semester of your studies, go back and study physics too. So, in the initial team formation on the first Scrum with the 10 people, I decided the team formation. So I tried to put people from different semesters, 2nd, 4th, 8th, and 10th. So that was the composition of the teams. Because in the guide, the definitive guide by Ken Schwaber and Jeff Sutherland, it says very, very exclusively that the teams are cross-functional. So the team you form must have all the skills to produce the product. That's why I selected more experienced students with less experienced students. About the second question, those 3 people that actually we have one dropout, so they left 9. One of them didn't show up for the exams. We don't know the reason. We asked him, but he didn't say.
He said to me, I will tell you.
What did he say? And the other one was just, let's say, not slow. He wasn't so much motivated, although that his team was quite motivated. Okay? So what happens to this? We don't really know, because right now we are in the beginning of our experiment. We will have more results this semester. But in order to complete the question, there is about the team formation. There is a version of Scrum dedicated for primary and secondary education, elementary, kindergarten schools, comprehension school, and high schools. And this is called the EduScrum, which is, from my point of view, it's much more difficult to apply that in a classroom than the original Scrum. In there is a special event called the team formation, and in the guide of the EduScrum guide describes that the teacher must form the teams in order to have each kind of personality in the team, because the EduScrum also targets to character and personal development for the students. So I was inspired by that in the first Scrum, and I say, okay, cross-functional teams, so I will make the teams. I had a view of how they perform, about their grades. That's why I got the teams mixed together. In this Scrum we are doing now, and we have 13 teams, I did a different thing. I let them form the teams by their own. This is the method that is used in Aalborg University in the PBL courses. So I had them in the auditorium, I gave them 30 minutes, and the 120 people that were present, in less than 15 minutes, they were already formed in teams. Only 11 people left out, and I made a team of those people, 10 people, sorry. But first I asked them, do you want to be a group of those people? And they said yes, no problem. Because I also asked them, do you want to go to another team that is already formed? And they said no. So that's how we formed the teams this semester. And I think that is a proper way of doing that, because the interaction of the team in Scrum are paramount. So we need them to communicate.
Yes.
That's why we use the PBL method of team forming by their own.
Yes, yes, I understand. It would be very interesting to see the results of this semester, where you have the whole class. Now, yes.
The students, they ask from all my courses,
Yeah.
to apply the Scrum
Of course.
as a part of their pedagogy.
Of course, but
they
you will.
want to learn by themselves, but also they have to be challenged during the personal interviews. You challenge them, you push them to the end, to describe you a real-life problem regarding electronics using their fundamental knowledge that they get.
Sure.
The amazing thing that I discovered is like how convenient they were to present things. At the beginning, they did not present, they did not ask, but during the process, they asked themselves, they asked, Manolis, and they are very fanatic when they present their work. And this happens because they are the owners of their work. It's not like the other group that I'm sitting to the lecture room and I'm telling them blah, 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 and then I ask some questions. Now they are the owners of their work. I think that this framework, how does it tell, combines whatever soft skills the employers need now if you read the future of the job. Collaboration, critical thinking, decision making, presentation skills. This is how I believe that we should train all of them. Of course, it's like a very extra job for any teacher. And for them as well.
Well, I don't think it's more job for them because they will.
It's more job than them because they have also to follow the lectures. They don't skip the lectures.
But they have to study anyway.
But they have also 2 hours per day just for this course.
Just for this Scrum, yeah. Anyway, thank you very much. Thank you.
Okay, regarding to the timetable, we are allowed to ask a last question. If you have more questions, you can ask by email. Maybe Manolis will share some tutorials or materials with us. Yes?
Yeah, of course.
Hi, Manolis. Thanks for the beautiful presentation. I have to ask a couple of questions. First, you did Scrum in 2, let's say, different types of projects. One was learning-based. The second was project-based. Did you notice any difference in the behavior and the outcomes of both of those types of projects? That's my first question. And second is, how did you deal with the blocking tasks? Did you have blocking tasks or some tasks that didn't allow for further continuation of the Scrum?
Okay, let's go for the first question, please.
Blocking.
I will get back to that. For the first question, the impression I got from the 2 different things, remotely and face-to-face, knowledge-based, project-based, it was this. In the project base, in the knowledge base, it was easier for the Scrum Master, okay? Because you have the product, you know what they need to learn. It was easier for the product owner than Scrum Master, in the perspective of the teachers. In the perspective of the students, that didn't make any difference. I had the same problems in both cases. So sometimes they couldn't meet because of time management issues and other classes, because also the Erasmus students that they made the device, they had also classes in our university. So they couldn't meet so frequently. So I have to alleviate this problem, to solve this problem in both cases. What else? I didn't see much difference in between those 2 cases because they are quite different. In the second case, in the project, in the actual product they made.
Manolis, I observed one difference between these 2. The people that they did the project-based project, because they designed by themselves the to-do list, they were more aggressive and more convincing during the presentation. Yeah. Because they have one more independence, let's say, option to design by themselves the pathway and what they should do in order to demonstrate the final product. They were more convinced and they believed more during the presentation what they were doing.
Thank you, Kostas. About the second question, I didn't understand what do you mean about blocking.
Blocking task is a task that cannot be completed in time and that have other tasks that depend on it. That, I guess, wouldn't be a problem in education base because maybe the student can skip a lesson for the meantime and continue with the other lesson to keep up with the rest of the Scrum team. But what about project-based when you have to finish something to continue further?
Okay. Scrum is dynamic. And by dynamic, I showed in the slide that you devise the product backlog, a list of items to do, and because you have to start somewhere. Each time you are free to put anything else is needed. But beware, if something is not working and you need to alter it, the product owner has the responsibility of erasing these tasks in order for the project to move on. Fortunately, in our first experience with the weather station, they were very competent. We didn't have this happening. And again, I stress to them that don't make it too complicated. They have, and everybody of us needs to remember that there is a rule in the market that 80% from the value of the product, 80% of the value of one product comes from the 20% of its feature. That was the rule I gave to them, and they were spot on. They didn't have anything less than what it was needed to have a working prototype. Okay? And that's a very, very interesting rule, the 80-20 rule. So you don't want to make your work too complicated. Keep it simple and working. That is the agile mindset. So we didn't actually have any blocking items. We didn't have to erase anything from the product backlog.
Thank you, Thank you, Manoris. Thank you for interesting presentation and for detailed answers. Good luck. Okay, our next presentation, just last presentation of the wonderful event. The speaker is Jason Cooper from Weizmann Institute of Science, Israel. Please, you can begin.
Thank you very much for the invitation to present a lecture here. So my lecture is not directly related to the ITEM project. Rather, like the lecture that Boris gave, it is to bring some insights from educational research that are relevant for the practices of teaching mathematics in university and for engineering and in general. I would like to locate my presentation with respect to Boris. So Boris spoke mainly about motivational and affective aspects of teaching. My focus will be more cognitive. So it will be about practices that for teaching that can be productive for achieving certain cognitive results. And it is very, very focused, you can see here, on giving feedback. So it is in the context of assessment, formative assessment. I will describe the idea in the context of asking students to prove a theorem, and then you receive the proofs from students, and the proofs are not perfect, and now you need to give some feedback. And I will talk about how you can formulate feedback for certain didactic purposes. But before I go into the theory of this, I think it is best to give an illustration of what I'm going to talk about. It'll be much clearer then. So I'm going to first give the illustration, then I'll give you a little bit of theoretical framing, define my terms, what I mean by heuristic proof refutation, or heuristic refutation feedback, and then I'll give you some more examples based on data. So first, an illustrative story, and this is a true story from when I was a teaching assistant at university for first-year students. And the students needed to prove that any non-empty subset of the integers has a minimum. So we're going to do some mathematics now. Everyone wake up. It's the end of the conference, the end of the day. But this is quite a simple theorem. Any non-empty subset of the integers has a minimum. Now, many of the students decided to prove this by induction, and they decided to do it by induction on the size of the subset. So, for n equals 1, it's very easy. A subset with one element, of course, it has a minimum. The member of the subset is the minimum. And now, if you have n plus 1 members, you can look at n members and 1. by the assumption of in the induction, the n members have a minimum. And now you take the minimum and you compare it to the one member left over, and the minimum of these two members is the minimum. So there I was marking papers and writing, giving full marks for this proof, because it's very elegant, very simple, shows that they understand induction. But then I realized that this proof cannot be correct. It is impossible that this proof is correct. Now, I did not see the flaw, but I saw that it is impossible that it is correct. Anyone want to tell me why it is impossible? Does anybody see a quick proof that the proof is not valid? This is what I saw. I saw that if you take the word minimum and you replace it with maximum, then the proof follows. But it's not true for maximum, is it? Is it true that every non-empty subset of the integers has a maximum? Do even numbers have a maximum? Do prime numbers have a maximum? Of course not. So something must be wrong with the proof. So this is what I will call in my talk false implication. I have refuted the proof by false implication. If the proof is correct, then it implies that every subset of the integers, non-empty subset of the integers, has a maximum. This I know is false because I have a counterexample, prime numbers or even numbers or odd numbers. Therefore, I have refuted the validity of the proof. Okay? What I'm going to suggest now in the rest of the talk is why this kind of feedback can be useful for students. Because let's think what kind of feedback I can give on this flawed proof. I could say, the proof is incorrect because induction works for integers n, and you have proven that for any finite subset of the integers, that it must have a minimum, okay, if it is not empty. Or I could provide the feedback that I, in fact, discovered when I was marking it. I could say, let's walk through some possibilities. I could say, your proof cannot be correct, because if I replace minimum with maximum, I get a false result. I could also say you get a false result because even numbers do not have a maximum. So I have a lot of flexibility how much detail I give in my feedback, and this I would like now to connect to the theoretical concept of proof comprehension. So this is an example of feedback that can develop proof comprehension, and now I would like to talk about this. So there is a lot of research that shows that mathematics lecturers want their students not only to be able to write a correct proof, they want their students to be able to comprehend a proof. Why it is written the way it is, why it is correct, why this line is written this way and not some other way, okay? Part of what I will explain now is a framework for what it means to comprehend a proof. Now, this is what students should be able to do. The problem is that, and this is based up by much research, if the feedback on the flawed proof is too prescriptive, it says you need to do this and you need to change that and you need to do some other things, students can fix their proof, but when you ask them why it needed to be changed, they don't know how to answer. Okay? So prescriptive feedback is not so good for proof comprehension. But when the feedback is not prescriptive, when you simply say there's a problem here, or what were you thinking there, or something like that, that does not tell students what to do, then the students do not know what to do. Okay? So prescriptive is not good. Not prescriptive is not good. What we need is a different kind of feedback, and this is what I'm suggesting here as refutation feedback. So the idea for this term heuristic refutation feedback comes, of course, I think it will be come as no surprise to many of you. This comes from Lakatos. Okay? So the idea in the very famous book, Proofs and Refutations, is that, just so I know, anybody here familiar with this book by Lakatos, Proofs and Refutations? Just a hand if you are. Okay, well, maybe it's not so famous then. Okay. The idea in this book is it's a beautiful book. It begins with a very nice theorem and then a very nice proof, and it's presented as a dialogue between a lecturer and students. And right after the proof, and the proof is very beautiful and very elegant, the next step is a counterexample. So you say, hang on, what's going on? We have a claim, we have a proof, and now we have a counterexample. This is not possible. Okay? So then they go over the proof, and they see why the proof allows for a counterexample. So they say, well, maybe our definition here is not so good. So let's change the definition, and now the counterexample is not possible. So then they find another counterexample. So it describes how mathematical knowledge can grow from a claim. You attempt to prove the claim. The proof is not perfect. You find some counterexamples. You change the claim. You try again. You see some more counterexamples. You change the definition. And it's a very long process of growth of knowledge through this process of proving and refuting. And there's been some work on why this is useful activity in classrooms, university, and mainly in high school. How engaging students in this kind of activity can contribute to their understanding and knowledge. So what I call a refutation argument is some kind of mathematical argument that shows, that proves that the proof cannot be valid or cannot be complete, like I showed you in the illustration. Now, I am relying on the work by Toulmin, who in the late 1950s analyzed argumentation, not just in mathematics. And for me, it will be useful to think of an argument as a claim, some data that backs up the claim, and a warrant that explains why this data supports the claim. Okay, so this is, in general, an argument has at least these three elements. And what I would like to discuss now, and this is the focus of the research that I'm describing, how can refutation feedback on a flawed proof engage students in activity that can be called heuristic refutation, and through this activity, contribute to their comprehension of the proof. So what we need for this is, first of all, to decide and agree what we mean when we say comprehension of proof. And what I'm proposing here, and of course you will see the slides, I'm not going to go through all of this, but this is some very nice work by Mejia Ramos and some colleagues, where they have interviewed very many mathematicians, and they have read very many articles, research articles on what it means to comprehend proof. And they have summarized this in 7 aspects of comprehending proof. 3 of them are local comprehension, comprehending perhaps one line in a proof, comprehending perhaps why one statement follows from another statement, and so on. And 4 of them have to do with the holistic structure of the proof. And I will come back to this, not now because it's too abstract. Once we have some more examples, I will come back to this and I will try to explain how the examples relate to this framework of proof comprehension. But this is really important because it's really, I think you will find it interesting to go over. Because if any of you teach proof and you're concerned with your comprehension of students, this is very, very useful for coming to terms with what it means for your students to comprehend the proof. Why is it stuck? Here we go. It's not working so well. Oh, I have to use my finger as a clicker. So, what is it that students must do when they receive this kind of feedback? First of all, they need to make sense of the feedback. For example, if the feedback that I gave was, this cannot be correct, because if you replace minimum with maximum, it's nonsense. So there's some making sense of this. Why is it nonsense? What happens when I replace minimum with maximum? So there's some cognitive work that the student must do to first make sense of the feedback. Once the student has made sense of the feedback, and perhaps if I did not give the counterexample, they need to construct the counterexample themselves, perhaps even numbers. They need to go over their proof and see why it fails for this counterexample, okay? Then perhaps they will realize that their proof only works for finite sets. Now, when they want to fix the proof, they must decide if they can just fix some small part of the proof and then it'll work, or must they completely change their approach? And in this case, I think you will agree that they need to change their approach. I don't want to keep you guessing, so I will tell you, in fact, the exercise had some instructions. So listen carefully what the instructions were. Prove by induction that if a subset of the integers has no minimum, then it is empty. Now this will work by induction, because we say, well, let's see if 1 can be in this subset. If 1 is in the subset, then it is, if we have a subset of the integers and 1 is in this subset, then 1 is the minimum. So, now our assumption is that it has no minimum. So 1 cannot be there. Can 2 be there? No, because 2 would be the min. If n is not there, can n plus 1 be there? No, because it would be the min. So this induction works. But the students, they tried a more direct inductive approach. Now that they see that this fails, they have a better comprehension of the correct proof. If they had just gone straight ahead and done it according to the instructions, their proof would have been correct. But they would not have understood the holistic structure of the proof, why it cannot be done by direct induction. So this already contributes to their comprehension of the proof. So, to show that this is just not some case, some theory that has one case, and it is in fact more general, I would like to show you at least 1 or 2 more examples. And here is one. I think many of you are probably familiar with this theorem. The unit square, this is in a course on set theory. The unit square on the real plane has the same cardinality as the interval on the line. This is a very famous theorem. But in fact, its proof is a little bit tricky. So, I will tell you how it's usually proven in textbooks. It relies on the Cantor, what's often called the Cantor-Bernstein theorem, that says if you have a bijection from set A to set B, and you also have a bijection from set B to set A, then there must exist an injection between them, okay? But the nice thing about the proof is that it doesn't necessarily, it's not immediate to what this injection what this bijection will look like. So, many of the students tried to prove, anyone want to guess how the students attempted to prove this? They had not studied the Cantor-Bernstein theorem yet. So what would you think would be a natural way to prove this claim? That there is the same cardinality for the unit square and the unit interval. What would be a reasonable proof, do you think? What is the definition that the students know for same cardinality? That there exists, of course, that there exists a bijection between them. So what do you think they might try to do? They might try to construct a bijection, yeah? Yeah. So it's quite natural, and in fact, many of the students did this. I would say maybe, I think all of the students did this. Now, how do you construct a bijection? Well, there's quite a natural bijection. I'll show you in a moment. I think I have this here. Yeah, it's quite a natural map. So if you take a point on the unit interval, you can think of this as a number between 0 and 1. This number has a decimal representation, infinite, of course, yeah? And if you want to take this number and you want to map it to a point on the unit square, then you can divide this decimal representation into the even places in the decimal representation and the odd places in the decimal representation. This will give you 2 numbers between 0 and 1. And these 2 numbers will be the coordinates on the unit square. So So it looks like there's a very simple and very natural bijection between them. But this has some flaws, okay? It has some serious flaws. One flaw is that one of the flaws in the students' proofs was that they completely ignored the question of uniqueness of representation. So where does this come in? It comes in when when the number has a finite representation, and you can either terminate it with an infinite sequence of zeros or with an infinite sequence of nines, right? How do you represent 1/2? You can either do 0.50000 or 0.499999. If you want to make this proof perfect, you need to decide on one of these representations and stick with it. This was one flaw. Now, the next flaw is based on this, because what happens if you now decide on your representation? Well, take a look at this, for example. Take the number 0.090909, okay, and repeating infinitely. Now, if you separate this according to the natural bijection, you will get 0.00000, that's fine. And you will get 0.99999, okay? One of these must be an invalid representation, okay? If you decide to go with infinite sequences of zeros, then the nines is no good. And if you decide to go with nines, then the zeros is no good. Now, I can tell you this is a very difficult flaw in the proof. And only one of the students that, whose work we checked managed to overcome this flaw. But for most of the students, in fact, it is necessary to do a completely different proof framework to overcome the second flaw. Now, here are some examples of feedbacks that a lecturer that my friend and colleague, in fact, this is a co-work with my friend Alon Pinto, and he interviewed a Berkeley a lecturer when he was doing his postdoc at Berkeley, and he actually documented much of the feedback that this lecturer gave on flawed proofs in this course. So let me give you some examples. So I'm now referring to the first flaw, students who disregarded the problem of uniqueness of representation with decimal, uniqueness of decimal representation of numbers. So here's one. Your map is not one-to-one. For example, now this is one student who decided to work in binary representation. I'm not sure why, but this is why you see zeros and ones. For example, 0.1000 and 0.1, and then an infinite sequences of zeros. So he gave 2 points on the unit, two points on the unit square that map to the same point on the interval, okay? So he gave an example. He, in fact, worked out a counterexample that shows that the reasoning is false. But here are some other, and we can analyze this argument. He said that f is not one-to-one. He provided some data. Remember what the structure of argument is? Claim, data, warrant. So the claim is f is not one-to-one. He provided the data. Data is 2 points in the unit square. And the warrant is that these two numbers do not represent, these two representations do not represent the same number. But here, look at some other feedback that he gave. Wrong, because real numbers are not in one-to-one correspondence with decimal sequences. No example. So think now for a moment, the difference in the work, the cognitive work that a student must do if he receives the first feedback or the second feedback, and how this cognitive work can contribute to development of the comprehension of the proof. And here is yet another example of possible feedback. Not true, and this is feedback that we saw. Not true because of the tails of nines and zeros. So here we have some data, but the data is not explicit. It is a hint. Try to construct the data for the refutation argument by looking at numbers that have tails of nines and numbers that have tails of zeros, but leaving quite a lot of work up to the student. I would now like to give another example, and it is not from a proof, a course based on proofs. This is in fact from a grade 8 mathematics lesson that Alon and I wrote an article on. It's a short article, quite interesting. I can give you some references to it if you like. I'm sorry, I'm going to skip on this because we don't have enough time. So this is some feedbacks, very quickly, this is just some feedbacks on the second flaw, the flaw that says that even if you decide on the uniqueness of representation, it is still very difficult to set up bijection. So one feedback was, what if x equals 0.0009191191? Pay attention here, this is actually quite interesting because it has some data. But what is the claim? What is the lecturer claiming here? What is the refutation claim? It's up to the student to understand what the refutation claim is and what the warrant is. So if we said that the argument is made up of claim, data, and warrant, we have data, but we don't have claim and we don't have a warrant. So quite a lot of work for the student here. And here's another example. Okay. Before I move on to this other example, let's just quickly see how this is related to proof comprehension. So let's think of some local comprehension of the proof. So students have to think carefully what it means that there is a one-to-one map between two sets based on the counterexamples. They need to figure out what the refutation claim, how the refutation claim is structured. They need to complete an incomplete warrant if the warrant has a claim and has some data and some claim but doesn't explain why this in fact refutes the proof. Or sometimes they need to construct the counterexample because the lecturer in one case said it is not a one-to-one map but did not give a counterexample, so it's up to the student to construct. And once you have the counterexample, you can work over your proof again, this time relying on the counterexample to see where the proof falls apart. Okay. Example number 2. This I found very fascinating. So I observed a recorded lesson where, to cut a long story short, the teacher and the students together constructed the following narrative, mathematical narrative. Root 18 is closer to 4 than it is to 5 because 18 is closer to 16 than it is to 25. Now I will let you think about this a moment. First of all, let me ask you, is root 18 closer to 4 than it is to 5? What do you think? Is root 18 closer to 4 than it is to 5? What do you think? Intuition. Yes. Nissim, why do you think it's closer to 4 than it is to 5? Okay, thank you. Now, you will agree, of course, that 18 is closer to 16 than it is to 25? So what we have here is we have a claim, and we have some data. What is the warrant? What is behind the because? So, first, let me give the story away, and then we can come back to formulating the feedback. What do you think, for example, about 20.4? 20.4. So, 20.4 is closer to what? 20.4 is closer to? It's closer to 16 than it is to 25, yeah? Because 20.4, because the middle is 20.5. So it's closer to 16. But thank you, Nissim, you told us that 4 squared is 20.25, yeah? 4 squared, it's 4.5, middle between 4 and 5. If you square it, it's 20 and a quarter. So we have here a number that is between 20 and a quarter and 20 and a half. So let me propose to you that the warrant that is not written here is, quite naturally, any number that is closer to 16 than it is to 25, its square root will be closer to 4 than it will be to 5. This is probably, I think, the warrant that the student had in mind, or the teacher had in mind when they said this. If this is the warrant, what can I now do? I can refute the proof, right? What is my refutation? What is the data for the refutation? 20.4, for example, because 20.4 is closer to 16, but its root is closer to 5. So what is going on here is more sophisticated than my first example. Because if I now want to provide feedback on this statement, and I consider this statement invalid, then I need to fill in by myself what I think the student's warrant is. I think the student's warrant is whenever a number is closer to 16, its root is closer to 4. Now, this gives me a lot of flexibility in providing the feedback. Do I tell the student what I think his warrant was? Do I leave it implicit? But once again, I can say, for example, wrong, think about 20.4. Now, I leave it to you to think what a student will need to do if he receives the feedback. This cannot be correct. Think of 20.4. There's a lot of work that the student needs to go through, but I think it's work that we just did it now. It wasn't so difficult. But for students, it might be more difficult to work out what the refutation is, how to fix the proof. So this is what we've gone over. So let's just quickly see what kind of engagement we have with proof comprehension. So we need to understand how the lecture is refuting, what the framework of the lecture's refutation is, what warrant has been attributed to the proof. I can say to the student, it seems to me that you think that whenever a number is closer to 16 than it is to 25, its root will be closer to 4 than it is to 5. But perhaps I do not say this in my feedback. Perhaps I leave this open, and this is a kind of engagement with proof comprehension that is necessary. I can give the counterexample, or I cannot give it. And I can provide some very nice feedback that is related to my very first illustration. I can say, well, what do you think about a number that is closer to 25 than it is to 26? Is it the same or is it different? Okay. Is it possible that whenever a number is closer to 16, its root is closer to 4, and also that whenever a number is closer to 25, its root is closer to 5? If this were true, perhaps the function must be linear, but it's not linear. So there are very many other ways to refute the claim if I direct the student's attention to the other half of the interval. I'm not going to go into example 3. I just want you to believe me that there is another example here. And with that, I think we will end. So this is another very interesting example that we present in our paper. Students needed to prove that there exists a polynomial with rational coefficients that does not achieve a maximum or a minimum value when restricted to rational values in an interval. Okay? And very many students confused local minimum with global minimum, local maximum with global maximum, and so there were very, very many flawed proofs. But in the article, there are some very nice examples of refutation feedback that does not say what is wrong with the proof, just shows this is not possible. And in fact, this is the name of the article that we hope will be accepted soon. This cannot be. This is the name of the article, the beginning. This cannot be. Your refutation feedback on flawed proof. So I think actually this is enough because we're running quite late.
Yes.
And if there are just a couple of questions.
Thank you, Jason. You gave us a lot of questions while we are tired, and we will give you a lot of questions again. It's a joke. So, what do you think the direct product countable direct product of the rational set of rational numbers is countable or uncountable. This is related to the bijection, right?
Well, it's an interesting question, but I don't think it's directly related to this idea of feedback. So if you would like to propose a flawed proof for a claim, and we can perhaps think together about feedback. But just the mathematical question is, yeah, it's interesting. But I think
it's interesting, right? Okay, more questions do you have?
As usual, thank you, Jason. And Jason, thank you for staying here all the time with your very interesting question. I would like to tell you that this year, helping by Israel leading the course, the Dean of Mathematics asked us to back to face-to-face teaching and start with the zero course, pre-calculus, for the student for the first year. And Israel and me decide to propose we are not going to teach regular mathematics secondary school. We are going to teach reasoning and proof course, preparing for a student that is doing mathematics. Okay? We realize that the best barrier, the big barrier for a student in the study of mathematics was the language and the reasoning. No, the problem was not if they know derivative, they know calculus. The problem is how they access to the language and reasoning in mathematics. Okay, we proved several times the same theorem. Square of 2 is non-rational, how you extend, and so. The student considered that was very interesting, but 2 weeks previous to start the course, it was not enough, no? We suffered a big controversy because many professors considered that we were teaching something that belongs to another subject and so. Okay, in your experience, how long do we take to train the student to analyze proofs, counterexample? Because the professor complains about the student. Complains about first years, they don't understand, they cannot prove nothing. Second year, they don't understand, they cannot prove nothing. They finish the mathematics program and they still complain. The student cannot. We have not teach them to do that. We have teach to repeat, to repeat. Israel and me defense that we need a subject dedicated completely along the undergraduate program in mathematics to reasoning, proof, counterexample, and discuss, okay? And not only a subject, really more than this. How long do we need, is my question in your experience. In order to drive this student to do this, to address this kind of problem, and has a box of tools that at least they can start, how long do we take? In what moment of the undergraduate program we can think that we have got that more or less successful flavor that the student can manage. Yeah. Because later we decide that some of the students go to do a PhD and they have to totally generate new results on mathematics, new proofs, and whatever.
Yeah. So thank you very much for this question because it's actually a very good summary for the lecture. So I think that the disappointing answer is that normally the students will never comprehend. But this is our fault. This is our fault. It's not their fault. Because it has to do with alignment of our teaching and our assessment and of getting across the message what we want them to know. So if we assess the students on the correctness of the proof, then what are they going to do? They're going to look up on the internet the correct proof, and they're going to copy it, and they're going to get full grades, and they'll never comprehend. So this requires a different kind of teaching practice. I can tell you what this lecturer in Berkeley does, but it is very, very much work. So what he does is, There is no exam in his course. He teaches some theorems, and he asks students to recreate in their own words the theorems that they have studied in class. And usually the students, well, they're clever students, this is Berkeley, so if they think they have a more elegant proof, or a shorter or a more direct proof, they will write it. And then he gives feedback, and he gives refutation feedback, because the proofs, if they're not copied from the book, they're usually wrong. And then they resubmit. And then he checks them again. And he gives refutation feedback again. And then they resubmit. And again, until he is satisfied. And we have analyzed in our work 6 cycles of flawed proof, refutation feedback, flawed proof, and slowly sort. Now, this gives a very clear picture of what this lecturer expects from his students. He expects comprehension of proof. He doesn't expect correct proofs. He expects comprehension. We need to find ways, less time-consuming than this, to convey to our students that this is what is expected. And we need to find ways of assessing it and of giving feedback that will encourage this type of... Because what we've been discussing for 4 days now is that students must not only be able to solve problems, they must be able to reason, they must understand, they must have a deeper understanding, and so on, how we do about it in the context of problems. This proving is just another case of problem solving, right? So this is just focusing the same question on problem solving in the context of proving theorems. Thank you.
More questions? Okay, Jason, then.
Just a few words to say goodbye. Okay, in the name of Israel, Antonio, Super Antonio, and the people technician that has been with us, we would like to thank to all of you for this day full time and this very, very gratifying experience. It has been a pleasure for us after 2 years and more of living away without meet and the possibility to meet all together and enjoy. We have really a very, very interesting talks, and I hope that your time here has been grateful. We are going to upload all the talks in the website, put the link to the videos, and also it will be posted in the web of the project. So for the future, we desire the best, and I'm personally thanks to Israel for the help, because me alone was impossible to do this, never in my life. Okay, thank you, people, thank you. 3 months in Jerusalem, everybody.
If somebody has the comments or feedbacks, you can. Okay, thank you.
Quitamos esto.